some quick questions that were asked on the day one homework for statistics. It asks you to create a histogram. It's not a super important thing for you guys to know how to do, but I can still show you regardless. So all of this data right here, you have to enter into a list. So list one is the easiest way to go. Take your time, make sure you get all 25 values in there. Then to create a histogram, you have to turn on your stat plot. So you're going to go to second y equals and turn that on. And then instead of a scatter plot, the third one in is a histogram, or essentially a little bar graph. So that's this guy right here. Hit enter so that that's highlighted, right? And then to be able to get it to show up, go to zoom stat. And what it should do is pick the best window so you can see all of it. So zoom 9, right? And there's your histogram right there. Now to actually draw it and have some accuracy to it, you can use the little like tracer to toggle through it. So what it's showing you along the bottom, oops, excuse me, let me hit trace. All right, is right here is it shows you the minimum is 24, but less than, or excuse me, minimum is 23, but less than 24. So that value are all the things from 23 to 24. And then the next bar is 24 to 25. And so on. Now, I'm not going to take the time to draw the whole thing out, but you get the idea. All right? If you arrow from one to the next, it's going to show you this, and it's going to show you an n value. And n is how many are in there. So this first one, there was just 1. So along the left-hand side is the frequency. So when you slide over, n was 3. So this is up to 3. The next one is up to 5, and so on. So that's how you can have the calculator do it for you. All right? Your other option would be to create like your own chart, but when it says describe the shape, all right, it's mounded in the center, so it's approximating a normal curve. But what I would just say is it's literally mounded in the center or something along those lines. All right. So that was the first question that was asked me, was 1A. The next one that I got was on question number, or excuse me, homework number 2. And that was number 2. So this one, I think the reason why sometimes people get thrown on these is that the notes calculated the probability, but it didn't take that next step. So this is a great one to ask about. So it says the amount of soda in a standard can is normally distributed. Those are those keywords you have to hear, with a mean of 12 ounces and then a standard deviation of 0.6. All right. So if the soda cans, if 250 soda cans were pulled to check the volume, how many would you expect to have less than 11.1 ounces? So let's pretend the question said, what's the probability it has less than 11.1 ounces? That's like what the notes looked like. So in that case, think about what you know. The mean is 12, standard deviation is 0.6, and we're looking for how many of them have less than 11.1. So I want to know, what's the probability that you'd be down in this little chunk right here? Right? So all I'm going to do is calculate the z-score for 11.1. So it's 11.1 minus 12 divided by the standard deviation of 0.6. So when I do that, let me get out of that histogram here. Minus 12 gives me a negative 0.9 divided by 0.6. It's actually a nice pretty z-score of negative 1.5. So you have an option. You can go and use the pretty chart, or just for the sake of what if this hadn't been pretty, how do I do it? This is where you can use the calculator. You would do a normal CDF, your lower bound, upper bound, mean, and standard deviation. Well, the lower, I'd be going from negative infinity, so negative 1 times 10 to the 99th power. Then I would go up to my z-score of negative 1.5, so that's what would go here. And then their mean would be 0. Standard deviation is 1. So let's find the probability you're between those two things. So as a little reminder, you're going to second vars and then normal CDF. So you're going to type in all those values. So I've already got the lower in there. The upper is negative 1.501. Okay. The probability comes out to be 0.0668 and so on. Okay. So it's saying the probability that you'd lay here. Now, if there's 250 of them, what's the chances? Just take that probability and multiply it by 250, because it's basically saying 6% or, almost 7% of 250. So take this, multiply it by the 250, and that's the same as having 16.7 or about 17 of those soda cans that fall below 11.1. Right? Because when you think about it, the probability, that's 6.7%, that's out of 100. So equals what out of 250? Like you could set up a proportion if that made more sense. Number 3 is the exact same type of question. So you just have to think about setting up between those two weights. So between 5.2 and 7.6. And so find the z-scores that correlate to each one of those, determine the probability that you're going to fall in between there. And then when it says, all right, they have 128 cats, that's a lot of freaking cats. If they have that many cats, then take your probability, whatever it comes out to be, and then multiply it by the 128, and that's going to give you your answer there. All right. So I just wanted to make sure to cover a couple questions that people had asked. The last one that I heard a question on is number 5. Honestly, I wouldn't worry too much about number 5. Not that I'm saying throw it out, but it's a little trickier than it needs to be. You're not quite given like information where you can directly calculate it. You kind of have to work backwards in this case. So when it's saying which of the weights could be the 90th percentile, you don't know if it's